Welcome everyone, this is your lesson for Volume of Prisms, Chapter 10, Lesson 4. Your learning target is to be able to find the volume of a prism. You'll know that you can do it if you can use a formula to find the volume, and you can use the formula for volume of a prism to find missing dimensions as well. So your key idea is volume of a prism. The volume of a prism is the product, so that means multiply. It's the product of the area of the base and the height. Well, you know that the area of the base is length times width, and then you just multiply it by height. This will work for rectangular prisms as well as triangular prisms. Even if you have a triangular prism, you'll find the area of the triangle base, and then you'll just multiply it by the height. So example 1 here, I feel like we may have even done one like this before in a previous warm-up. We're going to find the area of the base and then multiply by the height. To find the area of the base, we'll multiply base times height, which is 6 times 8, which is 48. And then we'll multiply that times the other dimension, which is 15. So 48 times 15, 720 yards cubed. So then here are your two try-its. Find the volume of the prisms. Notice for the second prism, again, it's kind of like that pink eraser where the sides are a little bit slanted. You're still just finding the area of a base and then multiplying by height. Okay, so for number 1, we're finding the area of the base, and the area of the base would just be 4 by 4. So 4 times 4. And then we're going to multiply that by the height, which is also 4. This is technically 4 cubed, and you can see that it is a cube. So 4 times 4 is 16, and 16 times 4 is 64. So that's 64 feet cubed. For number 2, we'll want to kind of look at this a little bit differently. We're going to find the area of a base, and this is technically our base, but based off of this picture, we know the dimensions, or the dimensions are labeled for this top portion. Okay, now please know they're the same for the top and the bottom. So area of the base is going to be 8.5 times 5, which is 42.5. And then you're going to multiply that by the height, which is 6. 42.5 times 6 is 255 centimeters cubed. So for example 2, we find the volume of a triangular prism. All we're doing is finding the area of the base. We're going to multiply by height. However, we always need our base to be the triangle side. So I'm going to highlight the triangle side here. So you may look at this and you may think, oh, that's not the base. It needs to be, okay? So to find the area of a triangle base, we're going to take 5.5 times a height of 2, and we're going to divide by 2. 5.5 times 2 is 11, and 11 divided by 2 is 5.5. Our height would be the 4 inches, so 5.5 times 4 is going to end up being 22, and our label will be inches cubed. Here are your two try-its. Find the volume of the prisms. Again, remember to find the base of the triangle part, multiply by height. And for number 4 there, even though it is slanted, your triangular prism is at an angle, you are given the total height being 3 meters. So for number 3, we're going to find the area of this triangular base, And that's going to be 5 times 12, divide by 2. 5 times 12 is 60, so 60 divided by 2 is 30 meters squared. And again, that is the area of this base. Now we're going to multiply that times height, which is 9. So 30 times 9 is 270 meters cubed. You could literally just take this and go 5 times 12 divided by 2 times 9. For number 4, it shows on the top here that the height of the triangle is 3/4, so that's technically the same on the bottom. So we'll go 3/4 times 2 divide by 2. That's going to get a little trickier. 3/4 times 2, that's 6/4, right? So that's 1.5. 1.5 divided by 2 is 3/4. Again, you could notice that those just cross cancel. And then 3/4 meters squared, that's the area of your base, this area. You're going to multiply that by height, which is 3. So we end up with 2.25 meters cubed. So here are 2 more try-its. Find the volume of the prism, the slanted parallelogram-ish prism for 5. And then number 8, that has 6 sides. So that's actually called a hexagonal prism. Please notice you're already given the area of the base. So go ahead and find the volume of these 2. So for number 5, we're just going to go 7 times 3, which is 21, and the height is 8. So 21 times 8, 168 inches cubed. And number 8 should have been the easiest of all because you're already given the area of this base, which is 197 times 25. 4,925 millimeters cubed. Okay, so for example number 3, each popcorn bag shown holds exactly 96 cubic inches of popcorn. Which bag should a movie theater choose in order to use less paper when making the popcorn bags? Use the formula for volume to find the height for each bag. So let's start with bag A. We know the volume is 96, and we know the formula for volume is area of the base, which is going to be 3 times 4 times the height, which we don't know. So as we simplify this, we're going to get 96 equals 12 times h. Divide both sides by 12. The 12s cross cancel, and 96 divided by 12 is 8. So for bag A, the height is 8. Now let's find the height then for bag B. Set it up exactly the same. 96 equals 4 times 4 times height. 96 equals 16 times h, because 4 times 4 is 16. And we divide both sides by 16. 96 divided by 16 is 6. So now that we have this information, we want to know which bag is going to use less paper. Go back to your prior knowledge. We just need to find the surface area now, don't we? Because we know that the height is 8. And we know the height of the shorter bag is 6. So now let's find the surface area of each, and we'll be able to figure out which bag is less paper. Okay, so for the bag A, the bottom, we need that. That's 3 times 4. So that's 12, correct? The front and the back, that's going to be 4 times 8, right? And 4 times 8 is 32. But there's a front and a back, so we need that twice. And then there's also a left and a right side. That's going to be 3 times 8, which is 24, but there's a left and a right, so we need 2 of those. So we don't have a top, agreed? You got to be able to put the popcorn in. So you'll have 12 plus 32 plus 32 plus 24 plus 24. I got 124 inches squared for the surface area of the taller bag. So now we'll find the surface area of the smaller bag, starting with the base. 4 by 4 is 16. The front and the back will be 4 by 6, which is 24, but there's 2 of those, front and back. And then the left and the right side is going to be 4 by 6. Which is 24, and there's 2 of those. So we have 16 plus 24 plus 24 plus 24 plus 24 is 112 inches squared. So even though both of these bags have the exact same volume, you will get the same amount of popcorn from each of these bags. The one that has the square base, 4 inches by 4 inches, is actually going to be less paper and therefore cheaper to produce. Now for the last of your video, try it. It says a stack of paper contains 400 sheets. The volume of the stack of paper is 140.25 cubic inches. Each sheet of paper is identical with a length of 11 inches and a width of 8.5 inches. So you're asked to find the height of each sheet of paper. All right, so here's how we'll get started. We know that the volume is 140.25. And we know that to find volume, you multiply length times width times height. The length is 11. The width is 8.5. And we do not know the height. So we'll go 11 times 8.5 to start us out here. So the area essentially of your base, if you were to draw a stack of papers, your base is going to be that 11 by 8.5. And that gives you 93.5 times H equals 140.25. So now you'll divide both sides by 93.5. Cross cancel. And 140.25 divided by 93.5 is 1.5. So your height is 1.5 inches, and you have 400 sheets of paper. So 1.5 divided by 400 is 0.00375 inches per sheet.